Hi everyone. Today we are going to talk about stability. In this case, we'll be talking about the closed loop system. And above here is the block diagram of a closed loop and feedback system. So we're going to use this block diagram to start analyzing the stability. So from this block diagram, we can find y over y set point, which is JCL, which is equal to Km times GC, GV, GP over 1 plus GC, GV, GP, and GM. And then this is when there is no disturbance change. So from this equation, we can say that this will be equal to GOL, which is the open loop. So let's start off by defining what stability is. It is when a system is stable if output response is bounded for all bounded inputs. And then we can do it like in the little, there will be a little graph for the real and the imaginary. So the criteria for it to be stable is if the real of S is less than 0. That's when we know it is stable. If it's greater than 0, obviously it will be unstable. So let's take this graph, for instance. This part of the graph is unstable, and this part of the graph is stable. And that's why if the real is less than 0, which is in this area, it'll be within this stable realm. And so in order to find if it's stable or not, we use the characteristic equation, which is 1 plus GOL, which equals to 0, which in this case is just our denominator. So let's just do an example where GP equals 10 over S minus 1, GC equals KC, GV equals GM, which both will equal 1. So from here, we can plug all of this into this equation, which is 1 plus KC times 1 times 10 over S minus 1, and then times 1, which equals to 0. So let's just write that out, which is KC 10S minus 1, which equals to 0. So let's just multiply this whole thing by S minus 1 so we can get rid of the denominator and just have it easier to read. So we have S minus 1 plus 10 KC, which equals 0. Then from here, we want to solve for S. We want to know if S has what S will be, just to see and determine the stability. So in this case, S equals 1 minus 10 KC. So S right now is all real, so there's no imaginary, so there's no I, so we can not disregard the I's and imaginary stuff. And from here, we want S to be less than 0. And in order to S to be less than 0, KC has to be a certain number or within like a certain range so that S is less than 0. So in this case, for S less than 0, we want KC to be greater than 1 over 10, which will make this a negative number, which will make S less than 0 negative. So that's how you find stability.